Hello everyone. In this video we are going to talk about the IUPAC nomenclature of cycloalkanes. In a previous video we spoke about the IUPAC nomenclature of alkanes. Please see the link that is given in the description. First of all, how different cycloalkanes are compared to simple alkanes? Well, their general formula itself is different. For alkanes, the general formula is CnH2n plus 2. But for cycloalkanes, what we have is CnH2n. Let's look at one example. 1, 2, 3, 4, 5, 6. This is hexane, C6H14. For cyclohexane, the structure in bond line notation will be like this. This is cyclohexane. Here we have C6H12. So, the degree of unsaturation in the case of alkanes is 0, but the degree of unsaturation in the case of cycloalkanes will be equal to 1. Let us just cross check it for C6H12. The degree of unsaturation will be equal to 1 plus number of carbon atoms, that is 6, minus number of hydrogen atoms by 2. So, what we have is 1, and that 1 contributes to the 1 ring. Let us look at their IUPAC names. So, let us look at some examples. We have a cyclohexane ring with bromine as a substituent, and we have a cyclohexane ring with bromine and methyl group as substituents. So, let us give names for these two molecules. Let us start numbering. 1, 2, 3, 4, 5, 6. In the case of monosubstituted cycloalkanes, you can either go clockwise or counterclockwise, and therefore the IUPAC name for this molecule is 1-bromo. However, giving the chain locator position is not mandatory for monosubstituted cycloalkanes. So, 1-bromo cyclohexane. The reason is you can also draw one bromo cyclohexane like that, and you can start numbering from there 1, 2, 3, 4, 5, 6. So, this chain locator position is not mandatory for monosubstituted cycloalkanes. However, the same is not true for simple alkanes. So, if we have 1-bromo hexane, for example, 1, 2, 3, 4, 5, 6, bromine 1, 2, 3, 4, 5, 6. This is 1-bromo hexane. Here the chain locator position is very important, because if you change the chain locator, then it becomes a different molecule. This is 2-bromo hexane. So, unlike the case of bromo cyclohexane, where the 2 became 1, the same is not true here in the case of simple alkanes, and therefore the chain locator position for simple alkanes is very important, whereas for monosubstituted cycloalkanes, giving the position of the substituent is not mandatory. That is a key difference that you need to understand. So, this compound's IUPAC name is simply bromo cyclohexane. Let us go to the next example. Now we have two substituents and therefore giving the position of the chain locator becomes important once again. So let us do the numbering 1, 2, 3, 4, 5, 6. On the contrary, if you do the numbering counterclockwise 1, 2 starting from methyl, so you still have 1, 2. The substituents are at 1, 2 position, whether you start from methyl or whether you start from bromine. In this case, we have a tie. Therefore, to break the tie, we have to use the alphabetical order rule, and therefore, the numbering scheme that is shown in blue color is correct. So, the IUPAC name is 1-bromo, 2-methyl cyclohexane. One common mistake students do often in the case of cyclic alkanes is they forget the prefix cyclo. If you are forgetting the prefix cyclo in the case of cycloalkanes, then you are totally meaning a different molecule, and therefore do not forget the prefix cyclo while naming the cycloalkanes. Let us go to next example. Now how about if we have 3 substituents, how we can go for the naming here? Can we start numbering from bromine as usual, as the way we did before? If we do that, then 1, 2, 3, 4, 5, 6, then the substituents are at 1, 3, 4 position. On the contrary, if you start your numbering from fluorine, it is 1, 2, 3, 4, 5, 6. Now the substituents are at 1, 2, 4 position. So it is basically the methyl group that breaks the tie once again. Remember, alphabetical order is important, but what is more important is whether you are following the second rule, which is once you decide the parent chain, we have to give the lowest numbers possible for the substituents, and therefore this is correct. So now let us do the naming. 1, can we start putting 1 fluoro? No, we still have to follow the alphabetical order. So the correct IUPAC name for this molecule is 4-bromo, 1-fluoro, 2-methyl cyclohexane. It's just one word. There is no hyphen here because no space is there. I am just writing it like that, but it is just one cyclohexane. Okay, 4-bromo, 1-fluoro, 2-methyl cyclohexane. That is the correct IUPAC name for this molecule. Let us say we have acyclic and cyclic systems combined together. In that case, how to do the IUPAC names? Number it first, both the acyclic chain as well as the cyclic chain, 1, 2, 3, 4, and then the cyclic one, 1, 2, 3. Here obviously the acyclic chain is longer and therefore that becomes the parent. By the way, do not start the numbering from here for the acyclic one. This carbon belongs to the ring. It does not belong to the acyclic chain. Some students do make a mistake. They start one from here and then make it a pentane. No, it is a butane. So, the IUPAC name is 1. This 1 basically refers to this. In parenthesis, cyclopropyl. We have 4 carbon atoms in the parent chain and therefore butane. Now, it is an alkane derivative and therefore, the chain locator position is very important, because let us say you have a molecule like this. What you will call that? 1, 2, 3, 4. This will be 2 cyclopropyl butane, isn't it? The chain locator position is very important when it is a derivative of alkane. However, for a monosubstituted cycloalkane, that is not the case. The chain locator position is not mandatory for monosubstituted cycloalkanes. Now, let us go to the next one. Here 1, 2, 3. The acyclic chain has 3 carbons and then the cyclic chain also has 3 carbons. 1, 2, 3. In this case, what to do? We have a tie. Whenever you have a tie between acyclic and the cyclic, then you have to choose the cyclic chain as the parent. This is your parent now, and therefore, the IUPAC name for this molecule is simply propyl cyclopropane. You can mention the 1, but that is not mandatory. This one now refers to this one. So, mentioning that one is not mandatory. So, you can simply delete that because it is a monosubstituted cycloalkane and therefore, the chain locator position is not mandatory. That difference you have to always understand. How about this? If we have a molecule like this, what do you call it? This will be isopropyl cyclopropane, isn't it? 1, 2, 3, but the group is isopropyl. You have a isopropyl chain here, but your parent is once again this one. Cyclopropane is your parent. Let us go to the third one. In the third one, once again number it 1, 2, you have a ethyl group and then the ring has 3 carbons and therefore, ring is the parent. So, this will be simply ethyl cyclopropane. You do not have to mention the 1 because it is a monosubstituted cycloalkane. Just to revise what we have learned regarding who is the parent chain. If the acyclic chain length is greater than the cyclic chain, then your acyclic chain is the parent. If the length of the acyclic chain is equal to the cyclic chain, then the cyclic chain is the parent. If the acyclic chain length is lesser than the cyclic chain, then cyclic chain is the parent. These 3 things you should always keep it in mind. But once again, when the functional group comes, depending upon where the functional group is there, things can change. So, let us look at more examples. Can you find out the IUPAC name for this molecule? Please feel free to pause the video and try to work it out yourself. Now, here we have 1 carbon atom here, that is it. How to decide the parent chain? So, when you have 2 rings, if more than 1 ring comes into the picture, then we have to name it as a derivative of the open chain and therefore, this becomes the parent now. Okay. So, The correct IUPAC name for this molecule is 1,1 dicyclopropyl methane. That is the correct IUPAC name for this molecule, because we had 2 rings, and because we have more than one ring, whenever you have more than one ring attached to a chain, then you have to name it as a derivative of the chain. Here length of the ring does not matter. You might think that no, I have 3 carbons here on this side, so I will take it as a parent. No. When you have 2 rings attached to a acyclic chain, then we have to name it as a derivative. How about this example? Please feel free to pause the video once again and decide which one should be the parent now. In this case, initially you might think that this chain is longer, 1, 2, 3, 4, 5, 6. So obviously that should become the parent. No. Here we have a functional group on the cyclopentene ring, not cyclopropene, cyclopentene. We have an alcohol, that is our functional group. Therefore, the numbering has to start from there, 1, 2, 3, 4, 5. So this is here we are making an exception to what I said earlier. When you have functional group, then things change. So the correct IUPAC name for this molecule is, we have to mention the hexanyl chain. So that is located at 2 position. So 2 hexanyl cyclopent 1-ene 1-al. That is the correct IUPAC name for this molecule. You can also mention it as 2 hexane 1-al if you want to, but that is not necessary. This will do. Thank you for watching this video, and if you do like this video, consider subscribing it to Chem Media for more useful contents. Thank you.